Today we're going to be talking about the angles of polygons with lesson 3.3. A polygon is a closed plane figure made up of three or more line segments that intersect at their endpoints only. So these are all polygons. So here we can see that when we're talking about the interior angles in polygons, it says to determine the sum of the interior angles, you can use what you know about the triangle sum theorem. By considering how many triangles there are in other polygons, for example, by drawing the diagonal from one vertex of a quadrilateral, you can form two triangles. Since each triangle has an angle sum of 180 degrees, the quadrilateral must have an angle sum of twice that, or 360. So essentially what this is telling you is that we know that the sum of the interior angles of a triangle are always 180 degrees. So by splitting these polygons up into triangles, we can multiply how many triangles by 180 to find the total number of degrees in each of the polygons. So here we have a triangle that's made up of one triangle. The quadrilateral we can take from any one vertex across to another vertex, and we can make two triangles. Now here, this figure has 5 sides, which is a pentagon. So I'm going to start in this bottom left and cut my figure into triangles. So this pentagon can be split into 3 triangles. Now go ahead and try the next 3 on your own. Now you can see that I have split these following 3 figures up into triangles. My lines I know aren't perfectly straight, but we can still count the number of triangles in each. So this figure has 4 triangles. This figure has 5. And this final figure has 6. So to find the total number of degrees in this figure, or this polygon, I could take 5 times 180 because there are 5 triangles. Now, let's take a look at that a little bit further. So here, for each polygon, we can identify the number of sides and the number of triangles. Determine the angle sums, then complete the chart. The first 2 have already been done. So we know that a triangle has 3 sides. It is made up of one triangle. 1 times 180 is 180. For a quadrilateral, we know it has 4 sides, split into 2 triangles. 2 times 180 is 360. So for the pentagon, we know the pentagon has 5 sides. And if we go back to the previous page, we saw that it was split into 3 triangles. And we can take this number times 180 to find that a pentagon has 540 degrees. We know that a hexagon, wrong direction here. A hexagon has 6 sides and is made up of 4 triangles. So 4 times 180 is 720. And if we had a decagon has 10 sides. It could be split into 8 triangles. 8 times 180 would be 1,440 degrees. Do we notice a pattern between the number of sides and the number of triangles? If n represents the number of sides, how can you represent the number of triangles? So think about n being the number of sides. What can happen to n to get from the first column to the second column? How do we get from 3 to 1, 4 to 2, 6 to 4, and so on? Well, each time they subtracted 2. So to write a rule, we could say that that would be represented by n minus 2. That would represent the number of triangles. So make a conjecture for a rule that would give the sum of the interior angles for any n-gon, so a polygon with any number of sides. So we know here that we've taken that n minus 2 and multiplied it by 180 to find the measure of the interior angles. Given this information, we can now use this rule to help us solve problems. So the sum, or S, of the interior angle measures of a polygon within sides is S equals n minus 2 times 180, where n is the number of sides. So find the sum of the interior angle measures of the polygon. So a heptagon has 7 sides. Go ahead and try number 1 on your own. Now, you should have started with your formula or your rule. The sum is equal to n minus 2 times 180. A heptagon has 7 sides, and we know that 7 take away 2 is 5. When we multiply 5 times 180, we find that a heptagon has 900 degrees in their interior angles. Go ahead and try number 2 now. Again, we want to start with that formula, n minus 2 times 180. An octagon has 8 sides. 8 take away 2 is 6. And 6 times 180 would be 1080 degrees. Now, let's take a look at a few more examples. So now we are going to use this rule and apply it to help us solve problems. So we can see here that we are given some angles, but we're missing an angle. The first thing we need to do is find out how many degrees are going to make this polygon. So we need to count the sides. 1, 2, 3, 4, 5, 6. So we can use our rule to find the total number of degrees. 6 take away 2 is 4, and 4 times 180 is 720. So we know that the interior angle of number 3 have to have a sum of 720. We can then use this to write an equation. So I'm going to start in the same spot. 135 plus x plus 125 plus 120 plus 125 plus 110 is equal to 720. You're now going to simplify by combining like terms. When we do that, we get x plus 615 equals 720, and we can solve for x by using our inverse operations. We know that x is now equal to 105 degrees. By looking at this angle, we could say that that answer is reasonable. We can tell that this angle is slightly greater than 90, or it is an obtuse angle, so our answer would make sense. Now, let's try number 4. We can see that this is a quadrilateral. Quadrilaterals have 4 sides, and we know that 4 take away 2 is 2, and 2 times 180 is 360. Now, we know that our sum of our interior angles has to equal 160. Go ahead and try to solve this one on your own. In number 4, they're requiring you to use your knowledge to know that this is marking a right angle or 90 degrees. When we combine those like terms, we end up with 285. And again, using that inverse operation of subtraction to help us solve for the missing piece. 360 minus 285 gives us an answer of 75 degrees. Again, if we look at angle X, we can see that this is an acute angle, slightly less than 90, so 75 degrees would make sense. Now, taking a look at number 5, 1, 2, 3, 4, 5 sides. So go ahead and find the number of degrees taken up by those interior angles. All right, I have finished that. 5 take away 2 is 3. 3 times 180 is 540. Now, when we're writing out our equations to try to solve, it's really helpful to go back and count to make sure that you have the right number of pieces or the right number of angles incorporated in your equation. I also like to start in one spot and move clockwise around the figure. That kind of helps me know that I didn't miss any information. So when we go to combine our like terms here, 2x plus 2x is 4x, 145, 145, and 110 makes 400. And we can use our inverse operations, again, starting with addition and subtraction. 4x equals 140. Divide by 4 on both sides to find that x is 35 degrees. In a regular polygon, all sides are congruent, and all of the interior angles are also congruent. So in a regular polygon, they're all going to be the same. So we need to find the measure of each interior angle of the regular polygon. So how much is one of those interior angles? Now, in order to save a little bit of time for the video for you, we have calculated the angles of an octagon before. So we know that an octagon has 8 sides or 8 angles. So 8 angles, which is equal to the interior angle sum of 1080, which we found previously in this video. Now to solve for each angle, we can simply divide both sides by 8. X would then be 135 degrees. So we're taking that sum of the angles, dividing it by the number of angles there are. So in number 7, we've calculated a decagon before in this video. So we know that a decagon has 10 sides and 10 angles and has a sum of the interior angles of 1,440. So again, we can divide by 10 on both sides to find that each angle is 144 degrees. Now remember, when we see the word regular, it means that they are all the same. They're all congruent. So now for an 18gon, this says that this polygon has 18 sides. We haven't calculated this one before, so let's go ahead and calculate this now. Go ahead and try this one on your own and come back when you're ready to check your answer. So you can see here that we take 18 take away 2 to get 16, and 16 times 180 is 2,880. We're then going to set 18 angles equal to 2,880 and divide by the number of angles on both sides to solve. 2,880 is equal to, 2,880 divided by 18 is equal to 160 degrees. So each of those interior angles measures 160. Now, on to the exterior angles. So the sum of the measures of the exterior angles of a convex polygon is 360 degrees. So all of the polygons that we're going to look at, those exterior angles are always going to add up to 360. It doesn't matter if the figure has 3 sides, if it has 14 sides, if it has 100 sides. It's going to have an exterior angle sum of 360. So let's take a look at number 9 now. So it says find the measures of the exterior angles of the polygon. So we are going to take our angles and set them equal to that 360 because we know that for a fact. These angles have a sum of 360. Again, I start in the one spot and go around. So 90x 90. That right angle, remember, is equal to 90. We have another 90 and another x. We have 1, 2, 3, 4, 5 angles. 1, 2, 3, 4, 5 pieces in our equation. Go ahead and combine those like terms. X and x is 2x. 90, 90, and 90 makes 270. Solve using those inverse operations. So 2x is equal to 90. Dividing by 2 on both sides to find that x equals 45. Now, going back to the question, it says find the measures of the exterior angles of the polygon. It doesn't ask us to find x. It wants the angles or the measures of all of those exterior angles. So starting here again, we know that we have a 90. We have an x, which we know is 45. we have a 90, and another x, or 45. So we can list all of the exterior angle measures like this. Now remember, the key here is that no matter how many sides of this polygon, the exterior angles are going to always equal 360.